Okay. Hi guys. How are you? I'm back. Okay. So let's look at the next chapter, which we'll be talking about. It's basically C++ stream input output. Right. This can be obtained from the drive that I've given you. Okay. And in one of the previous chapter notes. Okay. So as you can see, right, okay, we have a few chapters here. We're talking about stream output, okay, input, unformatted input output, and there are a few functions that we can see, read, gcount, write, and so on. Then we'll talk about stream manipulators, okay, format states, error states, and output stream and input stream. Okay, so as you know, C++ input output occurs in stream of bytes, okay. A stream is simply a sequence of bytes. I think all of you might know this by now. Input operation, bytes flow a device, okay, mouse to main memory, okay, that's an example. Output operation is when bytes flow from main memory to device, okay, it can be like a monitor, it can be like a printer, and so on. And bytes may represent ASCII characters, okay, and internal format raw data, movie, etc. And C++ provides both low-level and high-level input-output capabilities. So besides IOStream that you have been familiar by now, which is capable of input-output capabilities, okay, it also has many classes that handle a wide variety of input-output operations. One of them will be IOmanic, which is input-output manipulation, with which we will be looking at soon, where we call them parameterized stream manipulators. So you can see we have the input output stream, iOS, not the Apple iOS. This is the input output stream. We have iStream, OStream. We have IOStream, we have FStream, IFstream, and OFstream, which will be used on files, which we'll be talking about at the end of all our syllabus for this subject. Okay, so you can see here is an example code. You can see monkeys are really cute, cout, right? Or I can put it in two different cout. Two different streams, monkeys are, then cout, really cute. And I use a \n, then I can use the third method, monkeys are really cute, and I use one of the one of the functions called nline, endl, okay, for next line, which is similar to \n, but the way it is being executed or approached is fairly different. If you can see my son dancing around at the back, yeah, he's just joining in the fun, okay. Alright, so even for expression, you can see at line number 10, okay, cout 100 plus 39, that is basically a stream. Whereas in 11, there is an actual mathematical operation, which is 100 plus 39, right? And in line number 10, it is just a string, okay, and 11, it's real computable integers. And there are variations of it that you can do, okay, in line number 14 and 15, where you can see 100 plus 39, 100 plus 39. You can also use the \n, or you can use the brackets. You can use nline according to different precedents, however you want to do it. Okay, another thing is basically having character pointer string, where you can actually create dynamic array like char asterisk new string, woohoo, okay, so you automatically created a dynamic memory that has WOOHOOO, right? That is 1, 2, 3, 4, 5, 6, 7, 8 spaces with one null value at the back, okay, and you can actually print this value of string is new string, and you can print the whole new string woohoo, and you can find a static cast void new string. This is something to show you the address of wherever it is, but if you're not familiar with this text in line 11 and 12, it doesn't really matter, okay, it doesn't really matter. Okay, so this is what we call, as you can see, the reverse arrow is what we call a stream insertion operator. The arrow is what we call a stream extraction operator, which you use for input and output, technically speaking, cout and cin. Okay, and here are some of the example. Okay, integer x, y, enter two integers, and you can cin x, you can then y. Okay, overloading stream extraction operator, where you can cin two values at the same time. And then line number 16, you can actually use a selection structure, okay, where cout x, and you have a condition if X is equals to Y, there's a question mark. Okay, this is basically an if else, yeah, guys. And if it is true, then the string is will be printed. If it is false, then the string is not will be printed, followed by line number 17 equal to then Y. Okay, if I were to put this in if else, okay, it will be cout X. Then I have a condition structure. If X is equals to Y, then I'll cout is, else cout is not. Okay, that is how it is if I'm using if else. This should be something that you have learned in programming 1, I suppose. But if you are still confused about this, for next session next week during the quick Q&A, please raise this matter and I will demonstrate to you live, okay, over Zoom, right? And it's the same for line number 18 and 19 of how you can actually use this. All right. Sorry. So here is end of file. Okay, you know by now that you can actually use a Shift Z, right, to end certain loops. Like for example, if I have line number 16, I have while cin mux, while cin mux. Do you see the cin mux in the condition of the loop structure at line number 16? Okay, if you can see that, that means for as long as you see in a value that is valid, okay, and then the loop will keep looping, okay, while cin mux. So the first one, I put the value, then if it is true, then it moves on to the next one, which I key in 5, and then I key in 1, then I key in 22, I key in 4, I key in 88, I key in 9, I key in 1, I key in 23, for as long as all these numbers are valid, okay, and the operation of cin happens during as a condition in while, then the loop will keep looping, and keep checking for if mux is bigger than max mux, then max mux equals to mux. This is a very standard operation to find the largest number, okay. Then enter mux, then you get highest mux, max mux, right? Okay, until you put Shift Z or Z, okay, which is basically an invalid, or we call it end of file value, and it will stop the loop, right? Okay, next we start to get into a bit more of the functions that you can use. Some of it we call it get, and we call it put. Okay, so get function is basically a character reference argument, right? You can see it from this code. Okay, for example, char c, before input cin.eof, eof means end of file, cin.eof, end of file, enter a sentence followed by the end of file, right? So I'm going to key in good morning Mr. Kok, what's up y'all, right? And while c equals to cin.get, so I'm going to get all the character one by one, not equals to eof, line number 14, yeah, while c equals to cin.get, not equals to eof, then cout.put c, right? So I'm getting the alphabet one by one, G, O, O, D, and keep printing it out by using the put function. And cout eof in the system is, if there's nothing, then it's 0, C. But then after the input, you can see that the eof end of file has become 1. Okay, so you can use this, the get and the put function, which is fairly simple, but in many of our applications we don't really use this, just for academic purpose, right? We can also create an array, okay, like line number 9, we have a constant integer size equals to 80. I set the size of the array to be 80. Then char buff1 size, buff2 size, okay, I have 2 arrays, buff1 and buff2, and the size of the array is 80 and 80, okay, which can store 79 alphabets in total, right, in an array, with one null value to be reserved at the very end. So you can enter a sentence, cin buff1, okay, so I put there, good morning Mr. Kok, what's up y'all, right, and then the string read with cin is buff1. If you realize this, I think you have done this before with printf and scanf with C. You will see the same problem where whenever you have a space, right, whatever there is after the space will not be captured because the space acts as somewhat like an end of file, okay, like the